We already have a PageRank, so why to change it?
Because classical PageRank was built for a web that no longer exists. Today's web graphs are massive, millions, sometimes billions of nodes. And classical PageRank relies on iterative eigenvector convergence, which becomes computationally heavy as scale increases. So the question isn't why change it? The question is, what if we evolve it?
Evolve it how?
By introducing quantum-inspired computation. Not theoretical hype, not speculative physics, but practical simulation, using IBM's Qiskit framework to model ranking behavior through quantum walk dynamics. Instead of static probability transitions, we simulate evolving probability amplitudes across graph structures. That means dynamic probability propagation, multi-state ranking exploration, correlation modeling between nodes, structural influence patterns beyond classical Markov chains.
So what exactly did you build?
We developed a quantum-inspired PageRank graph visualizer, a hybrid system combining Qiskit for quantum simulation, NetworkX for graph modeling, NumPy for matrix computation, Matplotlib for structural visualization, Requests and BeautifulSoup for live website crawling. It performs three core functions: crawl a website's internal link structure, construct a directed graph of pages, compute and visualize ranking distribution. And it's deployable directly through Google Colab.
Okay, that is, now walk me through it.
Step 1. We crawl up to 50 internal pages from a domain. Step 2. We build a directed graph where nodes represent pages, edges represent internal links. Step 3. We compute PageRank scores using a structured algorithm framework designed to integrate quantum-inspired extensions. Step 4. We visualize the graph. Larger nodes equals higher rank. Directed arrows equals link flow. Scores displayed per node. And we output the top-ranking pages directly in the console.
Okay, but is it really quantum?
It's quantum-inspired, and that distinction matters. We simulate quantum walks instead of simple Markov transitions, state evolution across graph nodes, node correlation through entanglement-inspired modeling, potential future integration of adiabatic optimization. While current hardware limits large-scale quantum execution, Qiskit allows us to model and simulate these behaviors today. This positions the framework for future quantum-native implementation.
Okay, but from an SEO perspective, what's the advantage of it?
3 major advantages. 1. Faster convergence potential. Quantum walk dynamics can reduce matrix stabilization time in large graph structures. 2. Hidden structural correlations. We identify deeper link dependencies that classical PageRank might overlook. 3. Smarter crawl budget allocation. High-influence pages are surfaced faster, enabling targeted optimization. This is structural intelligence, not just ranking output.
And where does this go next?
Toward true quantum circuit-based PageRank adiabatic optimization for dominant eigenvector discovery. Enterprise-scale graph acceleration. Quantum-native search infrastructure. This isn't just a tool. It's a research-driven foundation for next-generation ranking systems.
So you mean to say this is more than just PageRank?
Much more. It's where classical graph theory meets quantum evolution, where SEO meets computational physics, and where link intelligence becomes future-ready. The web is built on links. We're redefining how those links are understood.